The problem I want to solve is the electricity issue when the flood happened in remote indigenous community. According to the previous research, this is some important and basic background information. I roughly divided them into two aspects, geography and environment. First of all, the Jigalong community I focused on is in the northwest of Australia. The community is on the edge of no man's land in central Australia. To the west, it is a town called Newman, but there is a high ground between two places as an obstacle. So the problem is that the surrounding area of Jigalong community has been divided into many pieces by the river, although the most streams are usually dry. Stream overflow when flood occur. At this time, the Jigalong community will be flooded by stream, but local housing and infrastructure facilities will be not washed away. This is not the same case along Australia's northern coast, where many houses would suffer very severe structural damage. I found that those floods basically come from north along the Jigalong Creek. It is generally caused by floods in the north or flooding of rivers caused by typhoons. Then I made a summary of the flood situation in the Jigalong community in order to find out my aim, direction for the design. Here are my methodologies. Right now, I'm in the initial design output phase. When looking at the environmental information of the Jigalong community, I found the entry point of my design. Then I checked the Jigalong's wind monitoring report in a government website. Go through local official website and records of government's construction project. I found out that the local community hospital has a small diesel generator. Locals use diesel generators to deal with emergencies when power is cut off by flooding. Now I get a more specific goals, and there are my design goals. Now I get some information and data of various parameters of existing products. Then I list the features I need. Existing wind turbines have different characteristics, from size to combination and top structure. The preliminary sketch. The first is the power generation and charging point of the upper part. I consider the three layouts for charging plug here. After clarifying the layout of the upper part, then it's the downside half. This area is used as social space. At the same time, the design of operating area was determined. Now I clear the structure layout, then refinement at the stairs, seating, and sunshade. Try to make the space below appear comfortable. Here is the lift structure. The main consideration here is replaceability after damage in remote areas, because the product cannot be maintained by specialized repairers. So I hope that all parts are modular and plug in with screws. This is the way anyone can replace the component as long as they have enough in stock.